Here's the camera. So here. I don't know why they can. Oh yeah, they unmute. Okay. Hello everyone. We're starting the workshop. One thing. So the workshop right now requires to use Open API right now. So like to use their API, it's really cheap. Overall, I expect you to pay at least less than like a dime for this workshop. So it's fine. Plus, you also get a $5 credit first time using Open API. So you just need to download the API key if you want to follow along with the code I have. And here is the code or something for sure. And also the code is on Google Colab to use, is on the Discord in the general chat. Okay. Next. Okay, so right now we're going to talk about large language models. So like, what is LLM? So you know how everyone here has used ChatGPT. So regularly, how this type of large language model use is like given a prompt, they try their best to complete the rest of the prompt. For example, ChatGPT, and usually there is one specific parameter that's very important when creating chatbot is temperature. Temperature kind of predicts how random the output is. For example, a model with high temperature can produce some coherent text, but it can give you some garbage. But even for you, as a chatbot, we want the temperature to be 0 to make sure that every student at UT have consistent experience. For example, in my code example, I have an example where they have 2 different temperatures being used. So here is this. 0. So first, when you start the code, you always have to start calling install everything. Then you have to set up the API key. Right now, the API key is in my .environment file to be used. So right now, we have to set up a LangChain chat, open API. And this is what the ChatGPT object looks like. So usually, when you want to create ChatGPT, you have to create a human message and content. And this right here is this one question right here below. Can I share my permits with someone else or register another people vehicle to my permits? That's actually a frequently asked question that UT students actually have. If you ask ChatGPT this one answer, actually good. See? As a LLM, I do not have the authority to provide legal advice or specific information about permit regulation and that sort, which is fine. And this side, the problem with our current goal right now is how large language models being used for UTD students is that sometimes those chatbots are made for the whole wide internet. Our goal is to make sure the chatbot can be used for UTD only, for UTD experience, UTD advice, and everything such. So here, I'll go back here, is temperature. So for this, I set the temperature to 0. This is one parameter that LangChain provides us to use. Is that you have ChatGPT with temperature 0. Let's say you prompt the model with the same prompt, same time, it should give you the same answer back. Here, that is the first one done, asking the model. And the question is, I paid at the bursar. This is a frequency asked question at UT student have. I pay at the bursar. So why is there still a hold/free on my account? And here is this. We have the same answer back, and you have ChatGPT as equal temperature equal to 0. So let's go back here. What happens when you set temperature to 1? And this is the highest value you can set temperature to be. So we have the same question, and we ask the model to ask the same question twice. Your first one? Here. It is, we have the chat. A pretty good answer. As a language model, I don't have access to specific account information, but they actually give a step-by-step guide how to solve it. And here is that first step is a processing. For the top one is processing, outstanding balance, late fee, and hold. And the second response with temperature high is a little different. It's a processing time, late payment, outstanding balance, and administrative hold, which is similar. But right now, our goal is to make sure that the chat model actually produces the same text every UC student to make sure we can guarantee good uniform experience. This is why for most chatbot in the world, you must set temperature to 0. So how does LLM read text? So we all understand that computers cannot read regular English at all. It can only read ones and zero. So what we have to do is to make sure the model actually, each time we have to map each word to a token ID. For something like ChatGPT and all-in large language model, the token ID can be huge, like around like 2 to the power of 10. So that's a lot. Like 10,000, like over 10,000 words. So, okay. Some words are too rare and misspelled, split into common word parts, and map this to IDs. So for example, we go back to our demo. We have token. So here, this is the get token function OpenAI use. For example, let's say I have this. TikTok is great. And we use the same ChatGPT token. And we can return the ID of each token represent. So right now, it's split up to many words together. To 6 words. And how much for this simple sentence is a 6 token. This is important detail to remember because ChatGPT, so how OpenAI charges you every time you use based on the number of tokens you give to them. So just a simple sentence like that can be 6 tokens. ChatGPT, they cost you around 0, like less, like 2 cents, or like less than 2 cents per token, per 1,000 tokens. Okay, so now we're going to talk about LangChain. What is LangChain? LangChain is an open source tool to help you compose a variety of language chains. For example, if you want a conversational chain, LangChain provides you. QA chain provides you. There are also lots and lots of chains. I remember looking up LangChain. There's one that can just use a calculator for you and do your math homework. So then we also have something called agents. Agents is the idea, if we have large language model, use Google search, calculator, tools, anything else, and use anything, just look things up, it can take actions in the world, do something about it. So your tool officer. So I want to also talk about how to track your costs. Use ChatGPT API. And LangChain does provide you a method to track your costs. You have to call get OpenAI callback from LangChain. And yes. I just want to part of key information about that. I remember just yesterday I spent over $3 on OpenAI costs. So we're going to talk about the next thing called prompt engineering. Prompt engineering is probably a new field of NLP. We try your best to prompt the model to get your desired output. So one method is called few-shot prompting. And few-shot prompting is that you provide a couple of examples to your model to make sure to guarantee the answer. So here, example, and evaluation few-shot. So here's an example of our model. So what happened here is that we load just a small code snippet right here. Our goal right now is to have the model to read through our FAQ dataset and put that into our prompt, into a QA format to make sure the model outputs a desired answer. Huh? Oh, I don't know. Right now. Okay, I'll stop you. Okay. Sorry for doing that. So next, we're going to talk about a different prompt. It's called chain of thought. So prompting, the goal of prompt chain of thought is to prompt the model to generate a sequence of short sentences to describe reasoning logical step known as reasoning chain or rationale to eventually lead to the final answer. And right now, I'll try to present you a good example. I just see here. Say 0 shot with LangChain. Let's say right here, I have a question. Let's say I have a calculus homework to do right now. What's the derivative of x squared? If I just call it and give me the answer, is 2x. But my teacher wanted me to show me, like, I'll show it step by step at least. So I'm going to do 0 shot with LangChain. So something called thought prompting, where like I put it in QA format. The question, what is the derivative? So right here. Here's something to make it easier for everyone to see. Can anyone see? Right here. So here. So all you have to do is to prompt the model to think step by step. All you have to say at the end, let's think step by step right here and here, and we can actually run it. What's the derivative of x squared? Here, actually give you the equation of derivative f prime equal n x to the power n minus 1. equal f squared. We have then for we have x squared is equal to 2x. So this is how we can have the reasoning of our prompt model. This is quite essential. If we want to have a chatbot going to every student's UTD, we should at least provide the reasoning to it, because we output a single answer, like it could be wrong, it could be right. But if we provide at least a step on how it occurred, we can provide more trust and make sure more people can use it. Next is extraction. Extraction is like you ask the model, what are you doing? For example, if I ask the model to say, do calculus for me, it will do better on my calculus stuff. So now we're going to talk about prompt templates. So prompt template is formatting by adding a variable right here. For example, I have a question and then QA. The goal of the user input were the prompt and a question answering format. The goal of the format method is to make sure the model think, hey, I need to answer a question. I need to provide at least a good answer. The goal is that to make sure the model is ready to answer my question. And also you can add history to your model to remember previous conversation. And third, currently, is that large language models are just having a slight difference on your prompt can give you wildly different output. That's why we have to have our model to use this. So we have our template, you are a helpful assistant to University of Texas. That will be the system message, making ChatGPT act like a professor. Then we have a human template. And return is that, as you see here, that's a human message. How do I remove a vehicle from my parking account at University of Texas, which is a common question that UTD students have. So next is we're going to talk about how we add history to our prompt chain. Right now, all you have to do is just add, allowing the model to remember current goals, to remember conversation. All you have to create is a new chain called conversational chain at the end right here. The goal is that you call predict. And for example, I have a question. Please tell me more about University of Texas at Dallas. And it actually generates a pretty good response. The University of Texas Dallas is a public research university doing access things, multiple things. Then let's say I want to remember conversation. So I'll say, what research is available? This is kind of a big question. So it must need to know the previous context of the conversation. So that's why the University of Texas is a wide range of research center institution covering diverse area of fields. If the model did not know what research is available, let's say any general advice, like hey, just go talk to your professor, he might give you something, but it did actually give you what type of research does your university do. So we're going to talk about document loaders. Document loader is like where to combine language model to what your text is, powerfully to differentiate them. The first step is to load data into a document for fancy-based things and piece of text. The model is making it easy. Let's see. Next, we're going to talk about vector database. The goal of vector database is to store a text, convert your text into vectors. And the only one operation those vectors can do is to get out a most similar matching vectors in the database. And the goal of it is to now select pretty good models also. And I have a cool example for y'all to follow. So right here is this. So right now your project does not have you have an FAQ data set to run, and this will go to use called a CSV document loader. Load your CSV file into link chain right here. And right now you see the first page is actually this UTD provides services for students with disability, and it'll provide you with an answer. This is it. Next, you have the first to choose your embedding model. Your embedding model is the type of neural network that will convert your text into vectors of fixed sizes. For example, here is that I have a text. This is a text query, the embedded query. Then the length of vector is 1,536. So what happened is that now I have to load all my documents into vectors and fit into my embeddings. Clear? All it takes like a couple of seconds, 2 seconds. Now I have to call a query in my queries. So then I have a question, like my parents are claiming me as dependent for federal income tax. This is a actually common question for UTD students to have. It's on the FAQ here. So I say do a similarity search, and this will retrieve some of the top documents. And right now we're going to look at the first document on top. And this will probably ask a question. This is actually a similar question that previous students have answered, and UTD actually probably was actually good answers. For example, my parents, similar question, and they actually probably was the answer. If you're claimed as a dependent by your parents for federal income tax purposes, then your domicile is presumed to be the same as your parents' established previously. And now we have a method to actually retrieve the most relevant answer from a previously asked questions. And then we can ask as many questions as we want for same question. So next, that is the power of vector database. So next we want to talk about this. So we're going to talk about use vector database to select few shot examples. As I talked beforehand, that we want the model to have specific prompt based on our own data set to generate answers that are similar to we have answered before. So basically the process is this. First, we create a list of examples in our CSV file. We load it, and we have to create a CSV selector object. This will load all documents into a new vector sort. After we have to create another prompt template. This make sure our model to have the same consistency as beforehand. Second is that this will help us make sure the model is grounded based on our data set. Plus, as the code example we have go on, do have an example, a few-shot example using semantic search. Here is that we have to create a semantic auxiliary example selector, which we have our example, which are QA format, question and answer. Next is that we have examples, then we have the embeddings, and then we have our vector sort. And tag K is telling us how much document we need to retrieve. So next we have our prompt template. This is our prompt template. Go for on, which would be Q and A, 2:, then our question, then our answer. And plus afterwards we have our prompt template here. So what does it actually look like at the end? What does the large language see as a prompt? So we use one question: how do I remove a vehicle from my parking account and University taxi at Dallas? And the prompt format should look like this. Our question: this is an example from our FAQ dataset. How do I remove a vehicle from text? Next, we have our own question. I need help. I need help from University taxi for your problem. This is our prompt. Is how do I? Then is how do I remove a vehicle from my parking account at University taxi at Dallas? This right now. So right now, as beforehand, we showed the model can kind of go out, not really topic. This should actually give us a good response. Here, this is what the model actually reproduced. To remove a vehicle from a parking lot at University of Dallas, you can contact a parking transportation department via email or visiting their office. So you'll need to provide the vehicle make, model, and license plate number. So overall, we have a large language model to answer questions based on the context of UTD. And one thing about few-shot prompting is that the more few shots you have, the better the response is on your evaluation. Go on. So next we're going to talk about how do we evaluate our text model. So usually we have a generative AI model have a question. Usually we can decide, hey, let's just create a data set. But sometimes our goal to answer like thousands of questions every day. So we probably don't have the target right answer to it. So the solution is to use a ChatGPT to evaluate their own text. That's the whole target. So we're going to use the idea from GPT eval, where the idea is that we just prompt the model to rate its own text. So right now we can prompt the model to rank a German text between 1 to 4 based on some metric like humanness, likeness, and other dialogue metrics. Afterwards, we take the average score value, how probable the model will select the score. So what type of metrics? For example, we have coherency, relevancy, and knowledgeability, and many more. However, the problem with this is slightly biased toward generative AI model text, generative text over human text. So this can be a problem if our validation data is full of generative text, like, okay, but some of our answers are human text. With pretty good answers, it might be biased towards itself over actual answers. So, here, I want to show that how do you have a prompt for it. We want to set the temperature at 0. We want to make sure the model here. Plus, we take average score. So the all codes show inside is actually in the Google Colab. So one question, does anyone have any questions? No questions? thank you. Original questions? Thank you. Probably go. Oh, at the end, I'll just go to the code example as we have. Want to? Just go ahead. So we have to. So I want to talk about hallucination. This is one problem that usually large language models produce. Just make stuff up at the same time. For example, is UTD parking good? And rate between 1 to 10. In the XML, it produces, hey, it's rate between 6 to 10. From our personal experience, UTD parking is slightly worse than that. Okay. Plus, one thing I want to share that I have one thing in the GitHub link, the one to go collab show. Also, I'm going to share a GitHub link, and this is return the. Let's see. I'll show in the GitHub link. We'll actually see what happens if we have a chat model. You use ChatGPT, given our question, and provide that answer. The whole entire link right here. If you want to see for yourself. That's it for. That's it for our workshop. Really fast. Wait, turn this off.